Hello again. This is a video for DCC 3, which is about electric current through objects in circuit diagrams. We've seen that electrons flow together along a path from high pressure to low pressure. This flow is called electric current. Notice there's a little connect symbol here to DCC 2. DCC 2 is about electric pressure and electric pressure difference. So since this is referring to electric pressure difference from high pressure to low pressure, it's saying, hey, check this out if you have questions about it. Here's where to remind yourself of what that is all about. We will annotate circuit diagrams to show current at various places within the circuit and use these annotated diagrams to make and test predictions. The first note we want to take here is as follows. This gets 2 stars because it is extremely important. This says, use arrows next to an object to show current through that object. Second part of this is going to make sense. A longer arrow shows more current. So just like we use the little H's and L's for pressure and we could notate pressure difference that way, we are going to use arrows to annotate current in our circuit. I'll show you what that looks like. Let's look at a simple circuit. It's not going to be the simplest circuit, but you'll see how helpful it's going to be for explaining electric current through the different parts of the circuit. I'm going to start with my battery, and I'm not actually going to annotate pressure on here because I want to focus on the current annotations. I want to show 2 bulbs that are connected side by side to the battery. And then they are connected to the other side of the battery. So I've got 2 bulbs here, and they're both connected directly to one side of the battery if we follow the wires through. I'm going to leave the dots off of this just to simplify my diagram. I want to focus on the arrows as the most important thing here. So we know that a longer arrow shows more current. We know that the arrows should show the direction of the current. Let me show you what's actually going on with this circuit. I have it built here so that you can see what we're actually talking about. These white wires here go to the 2 sides of a battery. So we've got our high and low pressure. And then we've got these red wires, which I've kind of curled up here to try to simplify it for us, that are basically going through this bulb from this point of the circuit to this point of the circuit. So that would be this bulb right here. And then these green wires go out to the other bulb. You can tell, I hope, by looking at this, that these bulbs are the same brightness. I'll turn this light off and remove this piece of paper so we can see, yeah, those 2 bulbs are the same brightness, even though they're at different places in the circuit. And we're going to say, just like we said that the same pressure difference means the same brightness, we're going to say that the same current means the same brightness. So I'll use, say, 3 little brightness lines on each side, so 6 total, to show that these are the same brightness. And then I'm going to draw an arrow next to this and an arrow next to this. Notice I have drawn these arrows the same length because both bulbs are the same brightness. So same brightness means same current. Through each bulb. So the arrow lengths are the same. Now, I'm not quite done here. The two bulbs are the most important objects in the circuit, but there's another object that I haven't annotated the current of, and that's the battery. I could also go through and annotate the current through the wire. So we have to do some thinking here. Before we finish this, I want to take some notes down here on, in general, how we analyze the current, how we annotate the current, and then we'll come back to finish this. This is not done yet. So let's take some notes down here. First thing we're going to say is arrow length doesn't have to be exact. Close is fine. So you want to get close to the same length. Like you might say, like, this arrow is a little bit longer than this. That doesn't matter. We want to be close enough to say those arrows are the same length, or this arrow is twice as long as this one, or whatever. This next idea is really, really important because we're about to see how this works in this other circuit. Current, as you've seen if you've done the labs already, current stays the same along one path of a circuit but I'm going to underline that. Current can divide if the path splits. So up here we have an example of the path splitting. So we see that this path from the battery splits at this point. I'm going to put an asterisk here and point out that this is a place where the path splits. So you want to use, maybe this asterisk is not your favorite symbol, but you want to show yourself somehow this is an example of the path splitting. And what that means is these two currents had to come from some larger current that split up into those parts. So what I'm going to say is the current entering that split was twice as long as either of the smaller currents. That is, I'm drawing this arrow twice as long as both of those arrows. This arrow plus this arrow is equal to that one. This current plus this current equals that one. Kind of similar down here. These currents join again, and these two currents combine to make this larger current. What does that mean about the current through the battery? Well, we know that on one path, the current has to stay the same. So the current through the battery has to be that twice as long current as well. So we could even make a note here reminding ourselves that a larger current has split up into two. I'm not going to do that in my notes, but if you want to make a note that this is an example of this down here, if that's going to be hard for you to remember, then you should do something in your notes that helps remind you of that later on. The last thing I'll remind you of here is that current can only flow in complete loops. So unbroken paths from high to low pressure on a battery. So for example, a broken bulb or a switch can block the current if you put it in the right spot. So one of the things you'll be thinking about is how to place switches so that they block the current where you want them to block the current. On this example, where you place the switch will affect which bulbs turn off, or where you disconnect bulbs will affect which bulbs turn off. I'll show you real quickly because this video is getting a little long. But if we think of this wire connection as a switch, notice I can disconnect this and this bulb doesn't go out. In fact, it basically stays the same brightness. Even though I'm turning on and off with effectively a switch, this bulb over here, because I placed the switch here, this is still a complete path. So this is a clue for how you can place switches to turn off individual bulbs. I can do the same thing over here. I can disconnect this wire and it turns off this bulb, but this bulb over here is unaffected. Because even if I switch this wire here, if I disconnect this wire, it does not affect the loop through this other bulb.